Hello and welcome back. Up until now, we have solved this problem using the beam elements, 2D plane stress elements, and 3D shell elements. Now we want to get a little bit ambitious and put these pins and convert the linear analysis into a non-linear analysis. And we will see that using the frictional contacts, how the results would be different when we just apply the boundary conditions over here. And we're going to start putting these pins here instead of just the boundary conditions. And this would be a little bit overkill for the beam analysis, but let's see how much time it takes and how difficult it is to solve it. So we first start with Ansys and never forget to change analysis type to 2D. And then we can select a plane and start sketching. So we have the rectangle over here and we just draw it arbitrarily, and then we can add a midpoint constraint over here. So let's create a construction point over here, and I wouldn't even need a construction point because I already would have an origin. There is a constraint and there should be the midpoint. And now we have the dimensions. It has to be, I'm gonna make it a little bit more than 50 inch. Oops, the units are crazy wrong. It has to be 52 inch, and since it's in mid, so I don't have to worry about it. The other side, and now we're gonna give it thickness. It's 0.5 inch. So we have our beam over here, and now there can be two things, like I can model the entire thing in one sketch, or I can do it in different one. Let's do it in different ones and then we can use that. So add material and thickness should be 6 inch. Hit generate and then we have our one body. I'm gonna hide it and we have one surface body. And now I'm gonna create 3 pins over here in one go. I'm gonna use one sketch to draw all of these 3. So I would make like 3 arbitrary circles, and but one thing I'm gonna do is I'm gonna create construction points over here, here, and at the mid. Now I can add dimensions to them because it's already on this line, so I would only have to give 0.5, and it's already on the axis, so I only have to give it 48, and likewise for the other side. And one thing we're gonna do, that we're gonna give all these 3 circles an equal radius. And we're gonna make this thing coincide with this thing, coincident, but we would still need a little bit more construction geometry to make sure that it stays over here, and we can drag it. Oops, maybe I draw a line and then make it vertical. No, I can't, and so I would have to delete it. So if we just look at the circle, we're gonna have, it has a center and then an origin. So its center should be somewhere over here, and then it's the other point. I would make it coincide with this thing, and we're gonna do the same thing with these things, these other pins. So, but we should not, rather not guess. So we draw a line, and then we create a circle. Oops, there is this circle, and then it would be like this, and the same goes with the other way. So we create a vertical line, and then we create this circle, and then we can later change it. And now we can delete these extra circles and add the constraint of equal radius to the pins. And it's interesting to watch that it didn't deviate from the center or the center line. And now we can, I'll maybe just put it there. I'll just keep it here, but I will remove the line, the vertical line, or maybe, and we are good to go with it. I still have to move this dimension over here. Now we have 3 pins, but they're too big, so we're gonna make them a little bit small, and let's give them a diameter of like 2 inch, and now it's gone off it. So let's try and do the constraint thing, coincident, and this thing with this thing, and this thing with this thing. Now they look appropriate, but nevertheless, even if its size was too big, it would still have a very small contact area. It's too far, or maybe they are already coinciding and it's just too big to show me. Nevertheless, we can create now surface from sketch, and I'd select second sketch, and instead of add material I would add frozen. And now I have 4 bodies. They are my pins, and here I have the beam. Now we are good to go. And since it is the 2D analysis, maybe the thickness would become irrelevant. We can look for it. Let's go to meshing now, and we can see the question mark over here, and then all of them needs an assignment. So we select all of these material to be A1, and nevertheless it has to be rigid, but at the moment we cannot do it. Like if I just select it rigid, then my analysis would not run, or maybe it would, but we can try it later on. So what we have connected over here is 3 connection points that are bonded. So we would want it to be frictional, or maybe let's make it frictionless, and behavior to be axisymmetric, and this is not the right thing. So at the moment we just leave it like this, and we go on to meshing. But for meshing we still need it to be a little bit good. So we select these faces and add the sizing to be 0.05 like last time, and let's try with meshing with it. But this is Again, it's a 2D plane problem and we wanted to have linear elements rather than quad. So we just clear it all and then generate mesh. So we have less nodes in it. And it took Ansys a little bit while to make this mesh, but it's too smooth. And we could have we could have, you know, like half as much elements if we should just cut it in half. These pins were half as much because the only thing we need here would be this region, and they could have half as much elements and our problem would be a little bit simple and easier to solve. But let's start with it for now, and we use the solver to be direct, and these edges we're gonna select. Oops, these two edges that we need to be fixed. Yeah, let's and see, because it is 2D plane stress problem and it shows you only XY components. So we have it fixed in XY, and then this edge we're gonna add displacement to -y, -3 inch, and we're gonna start solving it now, but add large deflections to be on because it's non-linear now because of the frictional contact. And one more thing I want to do is adjust to touch, maybe that'll help. So let's run it, and we're gonna make sure that we have a linear elements like 22,000 elements and 24,000 nodes. Yeah, so the experience has context status has experienced an abrupt change. What it means that you see there is some separation in it, and it did converge. Wow. So let's see the stresses, or deformation would be most important. Yeah, the contact never established, so it's gone somewhere. And we can see this thing 446 that was there as well. So let's try and change the contact to be ramping, and then we try it again. And again, I think we have the problem, or maybe no. Yes, we have, because now this thing goes separate, and we don't have a contact over here. So we're gonna find out what is causing it. So let's create a contact tool and then see which contacts are establishing and which are not. Now it's a little bit painful method to get it done. Yeah, all of these are open. So and they have this much gap in it. So we're gonna go to here and add, maybe that would help, or we need a minus thing in it. Let's not just guess, and we can try it. So we just copy pasted this value into the bottom, and now we have penetration. Wow, it worked. Sometimes if it doesn't work and the gap becomes twice, then maybe changing the direction would be better. So let's try it now, and maybe I can do it very small. So my initial time step is 0.1 and minimum is 0.1. So now I solve it, and then we can know like if it works or not. So again we have the same problem, and it's, well, it's converging, but I have to be very careful about it. So I'm just gonna stop it and then see what is happening. So it has gone somewhere, we don't know, and that is weird. But it could be because of this thing, like all of this edge is moving. and we don't know yet. So let's choose this face rather than the edge, and then solve it. And now again we have the same problem that is happening, and it could be because we didn't restrict this thing in the space. Now where is my third pin? And we can never guess what happened here. So yeah, so I guess the pin just kept rotating and then gone off. So it's not a good idea though, although we have the frictional contact over here. So it was supposed to be -3. It is -3, and the other pins are fixed. Now maybe we can overcome this problem by changing our boundary over here. Let's go to the geometry and cut it in half, and then apply the boundary condition on the bottom side rather than everything. So maybe it can happen. And we can trim it out, creating two lines, and let's try with it. So we have this line, and I would create a constraint, a midpoint between these two, and then trim it. Trim, da, da, da. And the same thing I'm gonna try with other ones, and I would create a line and add the constraint midpoint here, and then trim them. And the same thing goes on for the third one. So we have a horizontal line, and we add the midpoint constraint, and we trim it. And we just hit generate, and now we have a different geometry, and we can update it. Update geometry from source. Oops, now we need to apply displacements to here. And it also could be setting off because we applied it frictionless rather than frictional. So let's also try that. Make it frictional and make it like 0.1, and then we can try it, like run it. So the displacement is -3, and these are fixed in XY, and let's solve it. And now you would see that we would have less elements. So previously we would have, I guess, like 22,000. Statistics, well, 2000 was for just this thing, and because we updated it, it became obsolete. No, wow. Nevertheless, we can still wait. I was able to run it, but with a little success. So I had to switch these contact type to be frictional using 0.25 friction coefficient and using asymmetric, and convert and switching between the contact and target bodies. And the other thing that I did, I created a pseudo step or an empty step where just the contacts would be established, and I would have the beam fixed. Now I was able to run it, like for the pseudo step it converged, but then it just flip-flopped and it didn't solve, like even after like 10 tries using different options and step sizes. But we can still see the results, like we have a neutral axis and compression and tension. And it took me like 30 minutes to get to the point where I still don't have any results, and where a simple method would have sufficed. But let's try the same thing with the abacus. We start in abacus by creating a part that is 2D planar and that is shell. And again, we create an arbitrary rectangle and create a point at origin and fix it, and then apply the coincident to it. Do we have a midspan? No, midpoint. We don't have a midpoint over here. So, but nevertheless, we can still try with it. And this has to be like 52" and the same with the other side. It has to be 52" and the thickness is 0.5. Now we would just hit enter, and we're gonna create another part that is pin, and then we will in the assembly we're gonna use that part. So let's create it its diameter to be, or even its radius to be 1. And again we're gonna use only half as much to save mesh, and there is this trim, and there we have it. So we have two parts that share the same material, which is elastic 1.6 E6 and 0.3. Now because this is a 2D problem with frictional contact, it would have a significant impact by the Poisson ratio. So we apply the section that is solid homogeneous and material using the thickness, and but I want to do something. I want to switch this thickness to be 6, and I want to apply the same thing to this beam as well. Now we're gonna go to mesh and create the mesh for it. It's too big. Now we're gonna apply very fine mesh and hit yes. And it's really amazing how fast it is in Abaqus, whereas in Ansys it just took 2 minutes to create a mesh of like 5 times this size. Now we can have the same size, like 0.1 as the mesh, and I can split it and then create a better mesh. I can split the face using shortest path. Now it's not right, so I have to have used sketch, and done, and now we have a mesh. Now now notice that it changed the way it is, the way it was previously as well. And we can do the same thing to here and create a line over here. It's not the midpoint of this curve. Now we can have it at the same angle, like it's 45. So we can have it on 45 as well. 45 and done. And now we can see the change in the mesh as we refined. 0.05, and now it's really not needed to split it this much, but we just have it. We can just delete it, this thing, and then mesh again. So we have the part, we have the properties, we have the mesh, and now we need to create the assembly, which will be the difficult part, I guess. Auto offset. Now what we did not do was to create the partition on beams. Now we still want to do, we still want to make like the partition at 48-inch, and one in the middle. So we're gonna make it fixed so it doesn't move. Done. And we're gonna add this distance to be 48-inch, and this distance to be 48-inch as well, 48. And now we have done it. So we have these points which will be reference to it, and we can create the mesh again. And now we go to this, and we can keep adding constraints now here, this is the most difficult part here that people can miss most of the time. Now we're gonna select these constraints, parallel edge, and oops, it was supposed to be, but I can still use it. Now I can make this point to be on the very coincident point. This point has to be coincident with the one in the middle. And now we are done with it. And now we need 2 more pins, and we'll just add more part. 2, apply, and then another one, apply, and okay, or cancel. And they're just fine with it, like their direction is okay, but we still need to add this constraint, and we can apply to this point here. Now our model is set, and we can go on to create the boundary conditions. So we have, so we need to select these edges and the other 2 as well, and we're gonna fix it because it is in 2D space, so we only have X, Y, and rotation. So it is fixed, and the other one, we are going to only fix the U2. And the most important thing in it is that when the step is applied, it would have the frictional contact. So let's first create the step with non-linear, and increment should be 0.1, and maximum should be 1. So we just hit OK, and one thing we did wrong is that we fixed it all completely. It should only be able to support the Y, these pins. No, it has to be completely fixed, right? Because otherwise it's not the boundary condition. It has to support Y on this one. So this edge is completely fixed, and this edge has the motion of Y. So now we can apply it -3. Oh, oops, -3, and interaction. So we're gonna find contact pairs, and I could not find it. Maybe by 90, still no contacts. Axisymmetric and 2D models are not considered in contact detection. So we would have to create a manual contact, surface to surface contact, and it will be this edge. This is master and this is slave. It should have the contact of the intentional behavior, frictionless, penalty. Let's start with the frictionless and then we can change it. This is first contact, and now we're gonna use similar method to create these two. So I don't have to select all of it, so I can only select this one and I would be still fine with it. For example, if I section it like this, then I wouldn't have to select all of it. So I can partition it, so just the area that is in contact is my contact area, not all of it. And likewise the third one. And my slave. Now I already have it here, which is frictionless. So we are good to go, and maybe we miss some mesh, or no, we already have it. So I don't have to mesh it 3 times. I only have to mesh it or partition it 1 time and apply the properties 1 time as well. So let's try with it, and we create a job and with 6 processor, and we submit it. Now we can check it if it's running, and this is red, and I guess it's going to take a while. Displacement increment for contact is too big. Now this is why it was not running in Ansys as well. I mean, I can guess, we don't know. And we still have, now these are not yet converged points. But one thing I just love about Abaqus is that I can still go back and change things in it. For example, I can change mesh, and I can change so many things. So let's try and change mesh while it's still running. So I can make it like 0.01 and hit enter, and then okay. Now my mesh is a little bit too big to be solved, and how much mesh I do have? Mesh and detailed people, 577,435. Wow, that should take too much time, but I can reduce the mesh by making the problem a little bit smaller, 0.05, and enter, and then you go the same size, 0.05, and so we spend less time computing and more time on troubleshooting. Yeah, it's still too fine, and we can check it, it's about it. Yeah, that's good. Now we can change the step size to be 0.01, or maybe like 0.001, and then we submit it again. Now it did not give us success in Abaqus as well, and there's only a couple time steps that were converged. So let's see which one did, and results, and So we see nothing really, and there is, there it is, like stress is a little bit too low, but we see the same pattern going on like in a beam. So we have two high stress regions, compressive and tensile, and we have the neutral axis going on. But as the time passes, the problem becomes a frictional problem rather than the beam problem. So where do we have the highest stress? Over here. So let's switch from frictionless to the frictional model, and then we can try it. Maybe that way it will work. So interaction property, let's make it penalty and then make it 0.25, which is a little bit too much anyway. So we can submit again and then try. Now again it failed, and the displacement increment for contact is too big. Now the contact has to be refined, and if a non-unity thickness is specified for two-dimensional element, these elements are involved in interactions such as contact. The same thickness should be specified for the out-of-plane thickness of the corresponding surface under surface interaction. So there are three unconnected regions. They are not connecting now, and let's see, use out of shear stress, elastic slip, and penalty. Normal behavior we don't have, we don't want thermal and interactions, and so we can try with this thing, and or maybe we can switch the slave and master surface in all of these, and then we can try. And third one, and then we can submit it. But let's check if we did the right thing over here. It's -3 in U2, and so we have the positions, we have the bounds, we have the material, we have the right material, 1.6 higher power 6. That's okay, and three and three. That is correct, and everything else is as well. So we submit again, and we still don't have a success in it, and it just keeps saying displacement increment for the contact is too big. So let's try and solve it with the bonded contact. Let's try it in Ansys first, and then we can see like if it helps. So we have it bonded, and then we just leave it program controlled, and then we don't have the overclosure problem over here, and the large deflections are to be turned off because now it's a linear elastic problem. So let's try and solve it, and maybe it works now. And we were able to solve it in no time, but the directional deformation is 3 inch as we had the input, but the stresses are really crazy, like we don't know what happened over here, and the stresses are 214, and which is highest over here at the contact point. And now this contact is a bit too rigid. We can still see the neutral axis, but it's going haywire over here. We don't know like if it's trustworthy or not. And where is the highest stress? At the boundary, we already knew. So this stress is just because of the boundary and not because of there is a real problem in this beam. Now a lot of people might get confused if they see the similar kind of results due to bad boundary or bad problem setup. and they would think that they would need to reinforce this beam rather than correcting their FEA problem. So let's try the same thing in Abaqus and maybe it works very well. And instead of having these interactions, we would have the tie constraints. So let's kill them, and then we would have the constraints. So we have the master surface to be surface, and then select this region, and then slave to be this region, these two edges, and then we can just hit OK, and then we're going to create another tie surface. Master is this one, and we hit the slave to be these edges, and then OK. And now for the third one, we again create a tie, and the surface is this one with the slave being this one, and now we submit it. Maybe this time it works, we never know. Now one thing we didn't change in here was the nonlinear results or the analysis. The analysis was supposed to be linear, but we did not change it in the step. So we have the same kind of problem. We have the one mysis over 30,000 psi, and but now again we have some contact issues and not the real problem. So element here are going crazy. So I wanna only look what the beam is doing. So I would replace it and then see, wow, the stress is still there and it is highest on the beam, and we still see the U is 3-inch, but we have all the wrong results. Now what is the force over here? Force would be all of them, and force is 904. Wow. But it's wrong because now it's showing up everywhere at these regions and not so much over here, and also in the other side. Now we have a different kind of problem that we should have, and we can see that because this is a bonded to contact, so these elements are not, they just became stuck with it and there's no going back for them. And we can see the stress at all wrong regions rather than having an actual stress scenario. So this is what ambitions, this is where your ambitions get you, and you should always be worried about it. The idea of doing a good FEA is not to make a ridiculously complicated problem, but to make it simple enough so that you can solve it and get the most accurate results that you should expect. And this is why we need a mathematical support, such as solving these questions to find out whether our results make sense or not. Without these calculations or similar calculations, you would make no sense. Like, why wouldn't it run even though we have the same displacement and everything else? Like, it should be behaving like this, but it's not. And this is why mathematics is important, and solving or converting the problem into a mathematical problem first is very important. Let me know what you think about it, and have a very nice day. Goodbye.